Good day, math students. It's Mrs. Marcellus and my good friend Verkat. In this lesson, we're going to learn to write and solve multiplication equations. Today's learning objective is students will write and solve multiplication equations by applying the division property of equality and using standard algorithms. Today's vocabulary is division property of equality. If you divide both sides of an equation by the same number, the sides remain equal. The division property of equality is used to solve multiplication equations, and we are going to solve by dividing each side of the equation by the coefficient. And if you remember from previous lessons, the coefficient is the number that is multiplied times the variable. I think we ought to be able to handle this pretty easily, don't you? Then let's get to the examples. Let's solve the equation 6n equals 48. We will first need to locate the variable, and then we're going to isolate the variable. In order to isolate the variable, we will apply the division property of equality. We will divide both sides of the equation by the coefficient of the variable. In this case, that would mean we divide both sides by 6. When we write it out, it looks like this. We know that every fraction is a division problem, so this means to divide. The 6 divided by 6 equals 1. This leaves us with 1 times n on the left-hand side. On the right-hand side, 48 divided by 6 equals 8. Now we want n all by itself, so we don't want to leave that 1 there. The identity property tells us that we can multiply 1 times any value, and doing so will give us the original value. Therefore, we can drop off the 1 and simply write n equals 8. Now we will check our solution. 6 times 8 does in fact equal 48, so we know we have found the correct solution. The same algorithm will apply to decimal numbers as well. In order to solve this equation, we will locate the variable, then divide both sides by the coefficient. That means we will divide both sides of our equation by 5 9/10. Doing so leaves us with 1 times c, or c, and that is equal to 4. Then we will test our solution. We will multiply 5.9 times 4 to make sure that we do get 23.6. We have 3/8 times x equals 5/12. I'm going to show you two different ways to write this out and solve. The first involves complex fractions, and the second is a more streamlined method that you might find easier. We will need to divide both sides of our equation by the coefficient of 3/8. On the left-hand side, 3/8 divided by 3/8 does equal 1, and that leaves us with x. On the right-hand side, we have 5/12 divided by 3/8. In order to divide, we know that we turn the division into multiplication, and we multiply by the reciprocal of the second fraction. We could simply multiply straight across the numerators and straight across the denominators, which will give us 40 over 36. We also can look to cross-cancel values. The 5 and the 3 won't cross-cancel, but 8 and 12 can both be divided by 4. 8 divided by 4 is 2, and 12 divided by 4 is 3. When we multiply straight across, we get 10 over 9. 40 over 36 does equal 10 over 9 if we divide both the top and the bottom by 4. Then we would simplify. We turn the improper fraction 10 over 9 into a mixed number by dividing the top by the bottom. Therefore, x equals 1 and 1/9. To check, we would have 3/8 times 1 and 1/9, which is 10/9. When we multiply, we get 30 over 72, and if we divide both the top and the bottom by 6, we end up with 5 over 12. We also could have cross-canceled here. This would also give us our answer of 5/12. This is one way to approach solving the equation, but there is a second way that you can write this. We know that to solve the equation, we're going to have to divide both sides by the coefficient of 3/8. Dividing by 3/8 is the same thing as multiplying by 8/3. We can use this knowledge to write it a little bit differently. On the left-hand side, we would have the reciprocal of 8/3 times 3/8. Multiplying by that reciprocal reduces the coefficient to 1, and that leaves us with just x on this side. Then, in order to keep the equation balanced, we must multiply the other side by 8/3 as well. Now we could multiply straight across and get 40/36, or we can cross cancel, and this gives us our answer of 10/9, which is x equals 1 1/9. Whether you write it out as a division problem or multiply by the reciprocal of the coefficient, you will still get the same answer. Cats can make 100 different sounds. This is 10 times more than the number of sounds dogs can make. How many sounds can dogs make? Our problem tells us that the cat's 100 sounds are 10 times more than the number of sounds dogs can make. Our variable is going to be the number of sounds that dogs can make because that is our unknown. The 100 sounds the cats can make equals 10 times the number of sounds the dogs can make. So I'm going to write 10d to represent that. To solve, we will locate the variable, which is on the right-hand side, and we will divide both sides by its coefficient. When we divide both sides by 10, we end up with 10 equals d. This tells us that dogs can make 10 sounds. We will check our answer by plugging it back in and confirming that 10 times 10 does in fact equal 100. Let's solve our final problem. A cat named Dusty has the known record for the most kittens. In her lifetime, Dusty had 420 kittens. If Dusty had her kittens over a period of 15 years, how many kittens did she average per year? In her lifetime, Dusty had 420 kittens. This is the total number of kittens, so that is going to be on one side of the equation. She had these kittens over a period of 15 years, and the unknown is the number of kittens she averaged per year. So 15 times that unknown value that I will use k to represent equals a total of 420 kittens. To solve, we will divide both sides of our equation by the coefficient of 15. When we do so, on the left-hand side, we are left with k. On the right-hand side, we will divide 420 by 15, and that gives us a result of 28. This tells us that Dusty averaged 28 kittens per year. In order to check our solution, we will take 15 times 28 and confirm that it does in fact equal 420. Wow! I could not imagine having 419 brothers and sisters, could you, Furcott? And then having about 28 new siblings each year? Oh my goodness, I don't know how they ever remembered each other's names. Well, math students, this does conclude our lesson on writing and solving multiplication equations, so we're going to sign off for now.